Right, let's do a bit of a recap of last week, and we'll do it really quite quickly. We're going to go over this in what would become this session here, but I'm going to suggest we do that session a bit earlier if we're all up for it. We don't have to, we can stick to the original plan. I'm going to do a very quick demo of what we've done last week, but in Excel just now. And it has been recorded, so well, first of all, you can see we've got a new component open now. It's called Coursework 1, Compressive Test. This is the one where it'll look something like that, and it'll be compressed this way here. And you've got the code. I've given you the code. We've got the coursework brief. This is the brief here. We can look at that in a bit more detail during whenever that session happens. That's how it's marked, and the date for the hand-in is described in Moodle. There are some extra hints, extra help, notes that I gave some students years back. And there's the framework. Again, I'll go over that framework with you later on. I would literally copy, paste, and then start off a framework, but we'll talk more about that in this session, I think, or whenever we decide to do it. Okay, and I'm happy to help out with that. Right. Let's do an example. This one here, what you're going to do today, you're going to go downstairs in the lab at, I think it's 12 o'clock, I think it is. So we'll do this class, we'll have half an hour break, go out in the lab, and we'll do these tests. I'm hoping this does not take long. In years gone past, they used to use an old machine, and it would sometimes take ages. It would work, not work, and maybe work, and it was a total pain in the backside. We've got a nice, lovely, brand new machine. Guess what? I've been told this morning we're using the old one. Right. However, I've been informed that it works. It's going to take no time at all. And all we're going to do is place that literally on the machine like that, plate comes down, and it'll load it. You should already have read the document. You already know how long it will take to load. The load rate, you already know the load rate. You already know the questions you need to ask. My colleague Rashan, he will be there, not my colleague who you met last week. Well, she'll be there as well, but it'll be Rashan. He'll be operating it. You can ask him questions. He is a wood specialist as well. So you could ask him some questions that you need to write about in your report. You should have already have read it. If you haven't, you'll have half an hour between this class and the lab. So you can look at the document, read the things you need to ask. So what you're going to do is you're going to grab these, you're going to be 3 of them, yeah? You're going to measure with the calipers 1, 2, 3. Rotate it around 1, 2, 3, and you record those numbers. So for example number 1, the length, we'll only record the length once because you're not going to get 3 different lengths. Right. So you record the length once, there's my first one, and the breadth at 1, 2, 3, and the height 1, 2, 3. You do it 3 times. These are not the numbers you're using today. These are numbers from last year. So you'll have to use numbers we get today. So don't take photos of this. It's not going to help you. And then what we'll do is we're going to call this wet, right? Wet. And we're going to put this on a scale, and we're going to measure the grams, the mass of it, and you're going to record the grams. We'll do it on a whiteboard. So somebody will be on a whiteboard marking all this up when somebody else is measuring, and other people are asking questions. Then we're going to break it in the machine, break it, and we can discuss that when we're doing it. Then afterwards, all 3 of them will go inside an oven for 105 degrees Celsius for minimum 24 hours. Then a few people will volunteer themselves. I hope you do, because I won't be here. Will volunteer. You've got a class tomorrow anyway, haven't you? So you come in here, not here, to the lab. arrange a time with the technician, you'll take them out of the oven, and then you'll measure them again. And no, we're not going to measure them again because we've already broken them, but we will weigh them again. We'll put them back on the scale, and you'll get the dry mass. And you can see there's a difference between the wet and the dry mass. Now it's quite evident what the difference is going to be. It's just the water's been removed. Like all of the water will have been removed. And that's going to give you some information that you need. Okay? Right, that's the first part. And then you're going to get a lovely data set. Enable editing. We'll try and make this a bit bigger so we can see. Obviously you won't get that. All you're going to get is just that there plus that. That's what you're going to get. But you're going to get 3 different files. What I'm going to suggest you do is you copy them all onto the one document, i.e. 3 different tabs in the same document, like sample 1, sample 2, sample 3. And you'll also have the data, like I showed you there, which should be your measurement data. You'll have 4 tabs along the bottom. That's what I recommend you do. Well, actually, that's what you'll have to do, to be honest. Right. We'll go through this very, very fast, and we'll go through it again with another exercise that I'll show you later on in the computer lab. So we all know we can definitely do it. Remember, this is our sample here, yeah? I'll put it here. So, as we're breaking that, we know it's going to break and it's going to have an F max. That F max is fairly simple to find. So, there's our extension and there's our load. How the machine works is pushing down the way, so it's a negative number. And for our sanity, I want to reverse that in this scenario. So, all I'm going to do is go equals minus cell, copy, paste. Copy that and paste it all the way down. From memory, it should be 5020 data points. Looked at it last night. And all I've done there is I've just changed the sign. That's all I've done. Okay. The next thing I'm going to do, I'm going to graph it. I'm going to graph it now. So I've shown you how to graph before, data like this. We'll go insert. Remember, you'll be doing this later on today. I'm going to pick this one here, which is a scatter graph but with straight lines but no points. Move it out of my way. I'm going to go select data. I'm going to go add. I'm going to go data set. This will be samples. Sample 1. X value, quite easy, like that, go down, and then I've remembered the bottom row number happens to be 5020. Enter. Now I'm going to press my Y, like that, do that, go 5020. Oh sugar, I'm an idiot, I lost it. I'll do it again very fast. Spell. Sample 1. I thought I'd be faster than this, do apologise. There we are, press OK. And press OK. Good. There's my sample 1. Remember I told you last week this is sycamore. Sycamore's a hardwood. It's quite a dense. No, it's not dense. It's quite a light hardwood, but it's quite brittle. I'll show you that in a minute. It's quite a brittle hardwood, and it doesn't behave the same as a softwood might. So the samples that you're going to get for this module, all of them are all one species of wood. So all 3 different tests. I'm so delighted we've actually managed that this year, because I've never managed that yet so far. So this will behave slightly, yours will behave slightly differently. Yours will literally come up to it like that and then fall off a cliff. This one's not. However, it still behaved how we want it to behave, right? it's still got a maximum value somewhere around there, right? So all we're going to do, we're going to go into my cell here. Now, I'm going to be sensible. I'm going to take the name of that cell, or the text, go there and name it. I'll be fast as I can. Name all of these just now, because it's much nicer. Explain what they all are in just a second. I'm sure you've already sussed it out. Can you see that okay? Is it too small? Oh, good. Also notice one small mistake as well. And I'll go and just fix it now. Sample 2. You notice here all my variables are all fmax underscore 2, f1 underscore 2. So I've done that thinking it's sample number 2. Right. So if you've got 3 samples along here, make sure you name them correctly. That would be sample 2, and the next one would be sample 1, that would become a 1, or sample 3. Just do it properly, yeah? It'll keep your sanity a lot better. Right, fmax, we go in there and just go equals max, and it's the maximum load. And remember for me, the bottom of my page is 5020, but yours will be different from me. Show you what I mean. Just record that number there. What you need to do, just jot down a bit of paper, and then here I just go equals that there times 0.1. We said that last week. Same thing here. Fmax times 0.4. 10 and 40% for the elastic range. That's what we're trying to do. Now the average breadth, I can go here. What I'm going to have to do is to AV, I'll just go, sorry, sample 2, isn't it? I'll go equals, sorry, make it a bit bigger so you can actually see what we're doing. There, I'll go average of those 3, make it yellow, copy, paste. Perfect, I'll make that yellow as well. So these are the numbers I'm going to use. And there, average breadth, average height, length, average, just a number, because it's only a small sample. Okay, so that's got my dimensions now. I'm going to want to find, now that is a calculated number by 10% of that. However, I don't have that number in my data set. My data set is finite, it's not resolution. The resolution is not high enough necessarily. So I'm going to find the best match. So I'm going to go here, and I'm going to type in equals match. Don't know why I'm looking at that for. Go match, and then I'm going to take my value that I want to match, that one there, comma, and then the range that I want to match it from, and it's the load. Again, I'll put it to the bottom, 5020, this bracket. Exact same thing for my 40%. Then what I'm going to want to do is find the values at that match. Again, it's been recorded and we're going to do it physically in class together anyway, and with another exercise. It'll be really helpful for your next one actually. I'm going to do index. And with the index, I'm going to go my range, same range, just change that number for this one, 5020, comma, and the number I'm trying to find, which would be my row, bracket. You can see that number there is close to that, but it's not perfect, it's not bang on, but that's the actual calculated number, but that's my actual number from my data set. It does make a small difference, big enough difference to make it worthwhile to do this. You could just use these numbers here and you get it good-ish, but doing it this way, you get it how it should be done. Same thing, copy that. Move that down, and you see that number there is pretty damn close to that, so it's a pretty good match. And now I want, so that is my vertical or my y direction, or my load. I now need to find where my W1 and W2 are. I now have to find those. So I will use similar command. No, sorry, I will use the exact same command. Index. This time the range is going to be the extension. That's the horizontal here. My range this way. The same number though. 5020, comma, and then it's going to be that. And then do the exact same thing. Copy, paste, move that down. Cool. Excellent. Right. What I now want to do is I'm going to copy this and paste it. I'll move that one out of the way now. I'm going to take this one. Now what I want to draw is just the area between my 10% and my 40%. So all I want to draw now. This second graph. So I'll go in there. And I now need to do a bit of, so let me turn this off. I'm killing my hearing aid. Better. Right. I need to do a little bit of mental gymnastics here, I'm afraid. We can see this data set starts at cell 12. And we talk about the rows. The row, that's not necessarily, that's not the number corresponding to that. It's not that. It is the number corresponding to 1, 2, 3, 4, 5, 6. Make sense? So it's that range, it's the row within that range that we've set. So what I'm now going to have to do, again another bit of mental gymnastics, I'm going to not take the number 12, but I'm going to add on the number 11. Right? Think about it afterwards. If you want out, who cares? It's fine. So, just for easiness, if I can add 11 onto a number, I'll just go 11 plus that, the same thing. I go here, select data, I'll edit that, make sure I can see my numbers now. You probably can't see this, can you? It will be on the recording, and we will do it in the class later on today. So, but I'll show you what I'm doing. I'm going to take that 12, call that 4, 6, 4, and then do the same with that 12 down there. 4, 6, 4. Then I'm going to take that 5020. It jumps about like a lunatic. Give it half an hour. I'm going to change that to 971. I'll do the same thing here. 971. Press equals. Press OK. What we've now got is a graph of the data points that is only lying within the 10% and the 40%. All make sense? Easy. And now is the easy part, right? I just select the data, right click, I go add trend line. It's a cool thing, you know how to use it in Excel. Add trend line. We're going to display the R squared. Anyone know what R squared means? Quality of the fit. How good is the fit? And the trend line we're going to add, a mathematical trend line. You'll have done this in high school, right? You'll have done how quality of fits before. I want a straight line, a linear line. Remember what we said in week 2, and we said that we're going to pretend that this is a linear behaviour. That's what we said. It's a good enough approximation. Well, we need to make sure that our curve, our 10% and 40% is within range. If it's not, then we'll have to move our 10% and 40%, maybe make it 11 and 39% maybe. I have to do. If the quality of fit's not good enough, it tells you in the document BSEN 408 what the quality of fit must be. It tells you in there. We're going to display the R squared value. There's the R squared value. And you can tell me if that's, well, I can tell you right now, that is good enough. That is within 1%. Okay? That's within 1%. So, if that was 0.98 something, then it's not good enough. If it's 0.99, we're good, right? But if that's 0.98 or lower, then you've got a serious problem. You have to do something about it. You have to change where your data point is. I would just move it in the way a bit, try and get nearer the straight line. Okay, now we've got that, that's quite helpful. Whilst we're at it, what you can also do, also display the equation. You won't need the equation for this week's tutorial. Coursework, because this is the coursework you've got. You won't need it, but I think knowing how to turn on the equation would be helpful for your second one, okay? Now we've got that, we're actually cooking with gas now. And there's the full data set there. All we need to do now is take, get a shot of that. These two equations, complete them. So we've got equals F max divided by the area, the average breadth times the average height. Okay? And then E, again, fairly straightforward. Open brackets, the length times F2. Now, as I was trying to implement or say before, we could use these numbers here. Don't use them. Use these ones. There's the F1 value there, and the F2 value there, and the W1, W2. Right? Use those numbers. So F2 take away F1, close bracket, divided by, open bracket, average width times the average height, multiplied by, open bracket, W2, take away W1, close bracket, enter. There's your number. Not finished yet. We'll still have to get the moisture content of what that is. This is where your test method measurement data, you've got the dry and the wet, and perhaps some of this stuff here as well. And there's a document within the BSEN 408. It tells you which document to go and find, how to calculate this. I also talk about it in one of my lectures as well, but I would use the document and reference the document. Right, all makes sense? Right, cool. We'll go through this later on today. It gives a wee shot of it. There's other exercises as well. I just get a shot of that now. Oh, cancel it. Leave it now. Okay.
So see in the Excel thing, just put the moisture content thing, and then that's it. The whole Excel thing finished. It's just the SL.
No, you're not going to submit to me any Excel document. You're going to submit to me a written report.
Yeah.
We're going to go through that today in this session here. We're going to go through what you're going to give to me. You're not submitting to me anything in Excel. I want a written report. I want a lab report. Right? So you'll have to be there for that session, whatever that's going to be. It will be today. It's scheduled for 2 o'clock, but I think we can do it well before then. There's no point in staying here all day. Right. You'll need to do all of that Excel. You'll have to do it. I'll draw it here. You're going to have to do several things in addition to that. So if your first graph does something like that, your second one does that, and your third one does that, you'll want to have at least one graph talking about all three on the same graph. So you'll have literally, there's quite a few extra things you're going to want to do over and above what I've just shown you. I've just shown you the simplicity of what you're doing. It's pretty easy, fairly straightforward. Right, so that is for coursework number 1. And what you're going to do, you're going to write a written report. That written report, you're going to submit it to me, and there'll be no extensions, point blank, unless you're in hospital doing something. But there'll be no extensions, and the reason why I'm saying that is it's for your benefit, because if I give you an extension, then you're not going to get the feedback in time to use that feedback to make the second one better. So you need that feedback, the individual feedback, written feedback saying you've missed out this, or you've done that wrong, or rethink about this, right? So we want to get the first one submitted in. It's fairly easy. The second one's a bit more involved, but the format's exactly the same. We want the format to be tailored and suited. I'll show you how to do the second one. I'll show you the lecture for the second one. And the third one, to be honest, is different again still, but the format and the mathematics resemble the first one. Right? It's 4-point bending. Right, so it is honestly, Josh, you'll be fine. You'll all be fine.
The first one due, by the way? When is the first one due?
Sorry. It's the 3rd of the 3rd. There we are. 3rd of March. And remember, I expect, yes.
Sorry, just on the next coursework, it says 11th of November. I'm assuming that's not the actual date when it's due.
The next one?
Yeah.
You don't see that in the moment. You don't see that. You only see the ones that are not hidden. So, this module used to be a try 1 module. Yeah, so it's the 3rd of March. So on the teaching schedule, it's all written here. So 3rd of March, 10th of March, and the 7th of April. Fairly straightforward. Right, let's have a look at this week's. Sure. I wonder, can I where this works? One more thing. One more thing. We'll have to do it from memory then. Good. Right. No. Let's see if this works. Done something, I know it did. Not much luck with this device. It works sometimes and it works. And it doesn't work most of the time. Who cares? Right. So, one of the other things is standard deviation. I showed you this the other week there. I'm going to give you a very quick example on Excel just now. This is how we write it. But you need to know how to do it, and you have to do it by hand. Okay? But I want you to practice this, because when you come to do it in the class test, you'll have to do it by hand. And I'm going to be honest with you, a lot of people mess this up. It looks so simple, it really is simple, but they mess it up because they forget the basic steps. And you're not going to memorise it unless you actually practice it. Okay? So don't just be arrogant. You go, I know how to do that, that's easy. Don't be that person. So here's a data set of some numbers. I just put some numbers in last night. I totally forget everything that I'm going to try and do here. We'll try and go for it anyway. Right. So we're going to go count. How many are there? 1, 2, 3, 4, 5, 6. I could put 6 in there, or if I'm feeling fancy, I'm into Excel, I can go COUNT, open brackets, there's my range. Count. Average value. What you can do is you can add them all up. So you could just go sum all of that divided by 6. You could do that. Or you could just go average and you get the exact same number, okay? Quite easy. So far, so good. That's what that means. This here, the variance is that, okay? So we need we need to calculate this here, right? So what we'll do is we've got the average number, so I can make it more understandable for me. Copy that in there, in that cell. I'll go here, and I will go to myself. I'll go Fi. So Fi is the force or number, and I would be the count. So it'd be 1, 2, 3, 4, 5. So I'll go that there. Take away the average. Bracket, close bracket, to the power of 2 or squared. Easy. Put that down. If you do this by hand with a calculator and a bit of paper, make it neat. Don't rush it. You'll have an hour to do a question. You've got loads of time. Don't panic. Just take your time. Just do it properly. Yeah. If you mess it up and you try to be too fast, it just becomes a mess. You'll then regret having done this. So just take your time. So you do that. Through it again. It's the number there. Take away the average. Close brackets. Squared. All I'm going to do here, I'm going to go sum of all of that divided by count, or n. N is my count. my variance. And my standard deviation, before I do it, hopefully I've not made a mistake. I might have done. If I have, in Excel, there's an easy way for me to check, but you won't have Excel, remember, you'll have just a calculator and pen and paper. I can go equals, sorry. This is me double checking if what I'm going to get in a second is correct. I'm going to go equals S standard deviation. That's the number that I should get if I've got it right. Go here, go to the square root of that, and got the right number. Okay? It's that easy. That is the process. The number of students who mess that up in the exam or class test is shockingly too many. So don't mess that up. It's easy marks. Okay? It's all been recorded, so you'll get to play with that afterwards. Right, let's go back to the presentation. Yep, so you remember how to do that now. We looked at this last week. That's what we looked at in the first test. The second test is this one here. Right, and this is the grain going perpendicular. That is not actually the right size. Whoever made that for me messed it up. Right, I'll do that in a minute. This is what we'll be looking at today. We'll be looking at the perpendicular, hence why it's the 90, FC90, EC90, and we'll be looking at the FM, that's the bending moment, 4-point bending test. We'll look at that in the second part of the lecture. So for this one here, this is how it should be. Water. Nice to you. I've even given you a page number as well. See page 27 of BSEN 408. The breadth, height and length. Comes from this document here. The length should be, oh that's a valid point, it's probably right. 70 mil there, 90 mil there and 45 mil there. That's what it should be. And the loading goes there. And you can see, if you run your fingers down that, yes, this has been broken, this one. This was broken last year. There you can feel it's all been pressed really hard. So that was all flush and smooth before. Now it's all so that's after it's been broken. And yours will do exactly the same as that, I would imagine. Okay, this is where it gets a bit funky. Right? Funky, yeah. The equations look exactly the same, or they are exactly the same. I think it's different. The fact it's denoted by the angle to the grain, 90 degrees to the grain. Right. What's different about this one? Comparison to my last one, it's going to be the F max, isn't it? You're not going to get the F max by going maximum because it continues to get harder. Eventually, if you keep the load going on to the sample, it will eventually destroy itself and it will fall off a cliff. It's well and truly already failed well before then. The stiffness is gone. It's well and truly gone. Remember, it's the angle is the stiffness, essentially. K, the angle is the stiffness. By the time it's here or over there, that stiffness is well and truly shot. So it's no longer a stiff material. So F max, how we find that becomes problematic. The value for F max then, how do we consider that? My rule of thumb would be, have a guess. You pick a point, right? And you pick a point on the graph. You would start off with a sensible number, not just a random. Right, have a sensible number, look along the graph, something that's actually easy to find in your data set. I'll show you a trick later on today how to help you find things easy. Do that. And then the process is kind of similar from before. This time, we're not going to have approximately 10% and 40%. It's going to be 10% and 40%. You won't be allowed to go to 11 and 39%. It'll have to be physically 10 and 40%. You will take 10% of the Fmax guess and the 40% of the Fmax guess is what you'll do. You'll draw a line between those 2 points. I've already shown you how to do that, how to draw a line between 2 points. Don't worry, I'll show you again at some point, not today. But then what you'll do something a bit weird. You then have to draw the same line again. I've already shown you how to do this. I think I have actually. I'm sure I have, haven't I? I've shown you how to draw a line and then how to draw a line moved horizontally. I've done it in Excel, I've showed you in the tutorial. And if I've not, I can show you how to do it. But you'll definitely do that. However, you'll move it along horizontally a particular distance. It'll be 0.01 times h, the height. Okay? So you move it along 0.01 times h. Once you do that, this is an explanation of how to do that. Remember before what I was saying to you from tutorial, here, I said that having the equation of a straight line would be handy. Well, there's how you get the equation of a straight line of the fit. You also find the equation of the straight line of your 2 points if you want as well. However, you then need to translate that into an equation that gives you this. So I've been nice to you. I've given you that equation here. Giving you that equation there. I've also given you a link to the mathematical proof that that equation is correct. So what you now do is you see the intersect of that line that intersects your data. Find that point. Don't calculate a point, but you find that actual point where it does intersect. Again, I'm going to show you a technique how to do that today actually. You do that and you then want to make sure, is it within or more than 5% of the Fmax guess? If that is within 5% of the Fmax guess, you're golden. You're good enough. It doesn't need to be any better than that. Right? Do not waste your time trying to make it 4%, 3%, 2%, 1%. You're just wasting your time. It's good enough. Right? I have done that because I thought, well, somebody's going to ask me the question. I looked at what the results would be differing from what we're trying to calculate. Negligible. Right. So when I say it's good enough, just go with me on it. Within 5%, as long as it's within 5%, then we're golden, we're good. Just carry on. However though, highly unlikely that you're going to get your first guess correct. It's highly unlikely. If I were you, I would intentionally not get your first guess correct. If I were you. Because it means it shows me, because you can write about it, it shows me that you're following the procedures correctly. But if you just happen to guess correctly because one of your friends told you a number, it means you've not followed the process and you're not going to get the full marks. So I'm telling you, and it's on the recording, is if you happen to guess correctly the first time, that's your second guess, then make your new first guess and make it out. That's what I'm telling you to do. Because I want you to demonstrate to me the process. It's highly unlikely though you'll get it right first time. I'm just being upfront with you. So, if that were bigger than 5%, what I would do is move it marginally. Do not go moving it all the way up to there, because that would be miles off. If it is out by, say it's 6% at the moment, or say it actually is 5%, and it needs to be lower than 5%, move it marginally. Wouldn't go moving even halfway, move it just marginally closer. What I would do. I'd be more likely to get nearer the right answer. I reckon you'll do it in 3 moves, personally. So do this technique 3 times. So you want to record it as you're doing it and give me evidence that you've done that technique. Right, so once you've done that, then it's child's play. Because you'll recognise that equation, F max. It's just, the only thing that's different is it's 90. Right, okay. Maybe I should stop for a second. Let's find a decent graph. Yeah. If you're one of these people who wants to try and get a really nice mark, I up front, I'll be honest with you, I do give out 100% from time to time. The only people that get 100% are the people that are truly actually made the effort. So I think every year, but most years, it might be 1, maybe 2 people that will get 100%. But I'm marked anonymous anyway, so I don't know who you are. So I could be marking yours, but I could think it's somebody else's. I don't know. But when I'm marking it, I usually put just their metric number on, but I don't really care about who it is. What I'm saying is, if you're one of these people who wants to try and get a really high mark, you need to do some additional work to your graphs. So imagine that's my first graph. I want to see the first line. I want to see the second line. I also want to see that horizontal and this horizontal drawn on the graph. Color coordinate it as well if you want. Okay, it's not hard. I've already shown you how to do it. I've shown you in Excel in the computer lab how to draw straight lines on a graph, even at funny angles. So definitely do that. Don't just put in just the numbers and just the answers. You need to put a bit of effort, a bit of thought into it. If you can make your presentation, I'll go over with you, depends on the time we've got, I'll go over with you where all the marks come from, so you know exactly where the marks are valued. So it's not me plucking numbers out of the sky. You'll get the marks if you put the effort in. But I'll do that now. I think it's only fair. I'll show you the one for coursework number 1 is what I'll do. That's probably... They're applauding their lecturer. Oh, good lecture, good lecture. Is that what they're doing? EasyJet. No, it's not. Wizz Air. It's like flying in Wizz Air. In the land. Sorry, I'm rude. I'm very rude. I shouldn't say that. If you feel you want to applaud me, please don't. I'm an idiot. That's rude. That's very rude. Right, sorry. Okay, so our marks for the coursework. Presentation, 10%. So therefore, put some effort into it. Readability, 10%. Technical content, 20%. Does that actually add up? 60, 78. Yeah, it does. Figures and tables. Right, there we are. Figures and this is on Moodle anyway, so figures and tables is worth 30%. That means put effort into your figures and tables. Put the lines in. Talk about it. You know, don't just put a graph in and just some random numbers. Don't do that. Make some time and effort, and you'll get that 30%. and your conclusions. This is what I find more troubling. What conclusions can you make? That's what I do find more troubling to explain. However, it is fairly simple. When you look at, and assuming you've done all the mathematics correct, and assuming you've got your graphs nice and pretty, what are your conclusions going to be? You're not going to make a conclusion. We have tested this wood and we categorised this wood as C70 or something. That's not what you're going to get. You're not going to get that. Well, actually, you kind of possibly. But what you want to do is to follow this format. You want to talk about the test piece, test method, test results. And there will be information in there that alludes to conclusions. There's the failure mechanism of how it failed. You're going to take photos today. This is really a bad example, this one here. This is sample number 3 from last year. It's a terrible example. Is that an apple for the teacher?
I have to fight me for it, but...
Taking a piss. You're shocked.
I already said it this morning. When I seen it, I was like, oh man, what is it? Already.
Right. This is actually a really bad example because it's a hardwood. What you're going to get is quite different from this. You're going to get visible. Technically, this has got visible failures. You can see it's buckled slightly. But yours will be even more so. Yours will be quite telltale. It's going to be a softwood, and yours will fall off the graph. Hopefully 2 out of the 3 will be really evident. You're going to talk about what the failure mechanism will be, and you'll photograph it. So that's where your 30% will really come from, is the full information that's in there that you've concluded from the information. Make sense? It will make sense once you see the actual test, and the actual test samples. So it is worth 30%, so it's worthwhile thinking about what can I write, but do it in the context of this framework. Okay? And it is possible to get 100%. It genuinely is. So I'm not going to mess you around. Right. I want to talk about the last one. Again, this is last year's sample. I burnt the years before in my wood fire. I wish I hadn't, because these done something that I wasn't expecting. This is again sycamore, the same as that. This was not. This is a C16. Right? It's a different species, different grade, and it behaves quite differently. This is quite brittle. Yours won't behave like that. This will be in a few weeks' time when you do this one. It's 4-point bending test. So it's not the best. I'll keep the ones we do this year for next year. But however, it is correct. It's 4-point bending, and it did rupture, and it ruptured by a brittle failure. That's its failure mechanism. You could even talk. Last year, you could have talked about where about it failed. It wasn't right in the middle. It was to the side. And you could even talk about why that might have been. Statistically speaking, it would have been failed right in the middle. That's where the highest bending moment would be. It happened to be there. Or is that the case? We'll discuss. Right. So, how do we apply a moment to measure the bending strength? How do we apply it? So there'll be a test apparatus very similar to this. It'll be called a 4-point bending test, not a 3-point bending test, but a 4-point bending test. People do a 3-point bending test as well, but it's measuring a very different thing. What we're looking at is the bending moment. And that bending moment is that rotational stiffness. I usually have a ruler, don't have one today. but you can imagine the thing bending in the middle. The overall length, and we've got the A, so A will be the same distance either side, has to be, and then the bending moment will be F divided by 2, there was one ram separated out, F divided by 2 multiplied by the distance A, that's the bending moment happening. It's happening equal and opposite, like that, is what it's doing. Test apparatus. Set up for it. This is been extracted from figure 17 of BSEN 408. When we're doing these tests, some can be really small, like this, out of small clears. These are what we call small clears. It's a piece of wood totally void of any defects. Should be devoid of any defects whatsoever. The testing procedure or setup is exactly the same as what my colleague Wojtek would do when he's testing bits of wood the length of this room. Just that his bits of wood are much bigger and the machine he's using is much bigger. It's the only difference. However, all the 18 times H and 6 times H is all exactly the same configuration. The reason why we've got a bit of tolerance here, plus or minus 3H and plus or minus 1.5H, is just sometimes we can only get bits of wood or material certain section sizes, and also the apparatus that you might happen to have might be limited as well. Just that we're quite fortunate, but we've got a Centre for Wood Science, so we are quite fortunate that we've got different machines for doing different tasks. So fairly flexible. Right, FM is the bending moment. It's from this equation here. 3 times F max multiplied by A. Remember, that's A. Divided by the breadth times H squared. It is literally that simple. My word. Start at 9:30. 10:30. Right. So, what we've covered and all of that, we've recapped last week what we've done there. Today, we're going to talk about how to write the report for that. You'll do an example, and you'll also in this session here, during this session here, you'll actually break these samples, so you'll get the data tomorrow, and someone or some people in this class will go in tomorrow and get the rest of the data that you need for moisture content. Then you'll have enough by this time tomorrow, hopefully, to finish off the report for the 3rd of March. Your second coursework, this one, I'm really giving you an example. I'm not showing you how to do all of the Excel, but you know all the maths now. I'm showing you most of the Excel, what you need, but I've not done a live from start to finish. This is what you have to do. I'm unlikely to do that. Depends how if you're struggling or not. If you're struggling, I might give you a wee hand. Together, not individually. We'll see how we got on with this one first, and we'll see what help you need with this one. But you now know all the mathematics for this one. You might need a wee hand with that, to be fair. And this one here is super easy. It's the same format for the report. It's the exact same format, so it's copy out. First one, you do it, you get the feedback, you modify it, copy paste, change the maths for this. That time your format should be perfect. you've got your moisture content, you've got everything sorted, and it's looking good. You've got your 10% for presentation, 10% for readability. It's all great. Like, you get all of that, no question. Your graphs are smart by that point. You come to this one here, it's super easy. You're only calculating one thing only, and it's just that. Right. You'll still have, sorry, and the moisture content. You'll still have to calculate the moisture content and report that as well. Conclusions could be why you're doing moisture content. You already have that information, they've given you it in the lecture already. You have to look back and see, well, what did I just say about moisture content before? But you can talk about that in your what we're going to call conclusions 30%. So you've got all of that. I wouldn't bother with those videos. Those videos are useless. Right. What I'm going to ask you is, we've got 1 hour left on this lecture. Well, maybe not quite anymore. We've got about 40 minutes left of this session here. You want to grab our bags, walk over to E32. Hopefully it's vacant. I don't know if it is. Hoping it's vacant. Just jump and do this session in Excel just now. It should only take us half an hour. That's all it should take us. Do what I showed you this morning, plus one other simple exercise. That's all we need to do. And then not worry about that. I'll save you some hours. Because that starts at 2 o'clock, doesn't it? Yeah. That's 2 p.m. This is 12 p.m. And that's obviously now. So we've got about 40 minutes just now. We could do that session there now if you want. Or would you leave it how it is and go home at 4 o'clock?
Do the last one now.
Right. Let's just do that then, yeah? Let's just, so it's E32. Take a photo. Take a photo of that code as well, mate, and that as well. Yeah, I'm going to put out some extra tutorial stuff for you. The other mathematics things. Just for your entertainment over your holiday week. Sorry, reading week. If you get there before me, can you load up the Excel for our coursework 1, the sample? Load that up. Just a thing, for the, you know how you said you get 3 different Excel files? None of the actual, so it's like, obviously you're saying it's like 5,000, $20 that costs. Well, I was like, oh, no. I haven't put a single movie in the box, and I would like that's how you find that information. Yeah. The general is quite hard question, but I went in train class on a, I'm pretty sure I'm still recording that lecture. No. Go this way down faster. Yeah.